Okay, Mr. Penguin, I'm going to show you how to do this measuring liquid volume lab. Are you ready? Okay, first thing you're going to do is you're going to go to your Google Classroom and you're going to go up to the classwork and then scroll down to the measuring liquid volume lab right there. Okay, it says view assignment. Just click on the document to open it up. And here's the lab. Now let's go through what it says. Okay, so in this lab, the objective, we are going to be practicing measuring liquid volume with something called a graduated cylinder. Now, what is a graduated cylinder, might you ask? This is a graduated cylinder, okay? This is how we accurately measure liquid volume. And you'll notice that there are markings on the side of the graduated cylinder, okay? The numbers represent milliliters of volume, okay? So we've got 19 milliliters here, and we've got 21 milliliters here. So in the middle, that big line, even though there's no number associated with it, that big line represents 20 milliliters of liquid volume. Okay, so just like in the Penny Lab, we have background information that we should read and try our best to understand, because the background information provides you with context to help you to be more successful with doing the lab, okay? The background information also, it comes back into play when we do our lab analysis, okay? So when we write our evidence and reasoning part, we're going to use information from the background, but we'll get to that after the lab, okay? We'll review how to do that after the lab. For now, let's just take a look at the background information, okay? It says liquid volume is measured with a graduated cylinder. The unit for liquid volume is milliliters, okay? And the abbreviation or the label is ml. Each graduated cylinder has markings on the side that tell you how many milliliters of liquid volume each line represents. Understand how many milliliters of liquid volume your graduated cylinder represents before you use it. Next, because of surface tension, now if you remember back to the Penny Lab, that was the purpose or the objective of the Penny Lab, was to observe surface tension. And it formed a bubble on that penny, okay? It's the stickiness of water. In this lab, we're going to be observing a different aspect of surface tension. And this time, instead of a bubble being formed, something called a meniscus will be formed at the surface of the water. The volume of water is accurately measured at the bottom of the curved meniscus. Okay, now I have an illustration that I want to show you to help you understand just what the meniscus is. Okay, so I drew a little illustration of a graduated cylinder, and it's very exaggerated, okay? But this right here, this curved surface, is called the meniscus. Now in reality, it's not as exaggerated of a curve as I make it in this illustration, okay? So the point of this illustration is to show you where you're supposed to take your readings from, okay? The bottom of the meniscus, the bottom of that curved shape, is at 11 millimeters, okay? So if we were trying to figure out the volume of this liquid, we poured it into a graduated cylinder, we would read it as 11 milliliters, not 14 milliliters, okay? So when you're accurately measuring it using a graduated cylinder, you have to take into account this meniscus shape, and you take your readings at the bottom of the meniscus. Okay, so we have our list of materials. Okay, we've got colored water, we've got a test tube stand, we've got 6 test tubes, we have a graduated cylinder, and we have a pipette. Okay, let me show you those right now. So we've got a container that has blue water, and it's just water with food coloring in it, guys. We've got red, and then behind that we've got yellow. Whoop, this is our pipette. So we're going to use this to stir, and we're also going to use the pipette to really get good, accurate measurements into the graduated cylinder, okay? Graduated cylinder. And we've got our test tubes in our test tube rack. So we've got A, B, C, D, E, and F test tubes. Okay, so just like the Penny Lab and all the formal labs that we do, we have a section called the procedure. And in the procedure, this is the step-by-step recipe, so to speak, that you follow to accomplish the lab. So right now, we're going to skip the procedure. I'm going to do that in just a minute. Okay, I want to show you the rest of the lab sheet. Here we have our data table. Okay, we've got our 6 test tubes. Okay, A, B, C, D, E, and F. All right. When we're all done with all the steps in the procedure, at the end of the lab, we're going to complete the data table. Okay. So when you're all done with all these 9 steps, then we're going to fill in the color of the water in test tube A, and then we're going to fill in, we're going to make a judgment and write down the color that we see in test tube B, C, D, E, and F. And then what we're going to do is we're going to measure the final volume of the colored water that's in each one of these test tubes. Okay? And the way we're going to do that is, again, we're going to use our friend, the graduated cylinder. We're going to take the test tubes with colored water, we're going to pour it into the graduated cylinder, and then we're going to record the final volume when we're all done. Okay? Okay. So, before we start doing the lab, just like the Penny Lab, we're going to do our claim first, okay? We're going to make a guess. And so what I want you to do right now is I want you to come up with a 1-sentence response for the question that's in the claim, okay? And it says, which test tube do you think will have the highest final volume? So when we're all done with the lab and we go to measure, all right, sorry about that, I just had a little coughing fit. All right, so when we're all done with the lab, we're going to measure out the final volume in all the different 6 test tubes. But right now, you're going to make a guess, and you're going to write a complete sentence for your claim. Okay, which test tube do you think will have the highest final volume? Okay, so pause the video right now, and you're going to type in a sentence and you're going to say, I think that test tube, and then you pick A, B, C, D, E, or F. I think test tube blank will have the highest final volume. Pause the video and fill out the claim, and then come back. Yeah, so I just thought to myself, how are they going to be looking at this video and their lab sheet on the Chromebook? How are they going to look at those 2 things at the same time? So, I guess you're going to use this video as reference, and you're going to have to pause it, and you're going to have to go back and forth between the lab sheet and this video, okay? But what the main point was, I'm just going to read the procedure, and I'm going to do what the procedure says to do. You can pause the video and refer back to your lab sheet to read the procedure that I'm doing, okay? So for now, let's begin. Step 1, it says, into test tube A, add 19 milliliters of red water. All right, so let's do that. Okay, so if we are measuring from the bottom of that curved surface, that meniscus, it looks like I poured in a little bit too much of the red. So now I'm going to take the pipette and I'm going to take some out to get a nice, accurate 19 milliliters. Okay. All right. I need to put a drop back in. There, let's call that 19, okay? So pour that into test tube A. Step 2 in the procedure says, into test tube C, add 18 milliliters of yellow water. 18 this time. All right, so let's try that. Okay, there we go. That's pretty close. Maybe I need to add one more little drop to get that meniscus right on the 18. There it is, right there. Okay, 18 milliliters of yellow. And now we're going to pour this into test tube C. Step 3, into test tube E, add 18 milliliters of blue water. Let's see how we did. A little bit more. See, I'm adding it with the pipette, one drop at a time. There we go. Okay, and that's going to go into test tube E. Okay, here we go. All right. So the next step, it says, from test tube C, take 4 milliliters and pour the 4 milliliters into test tube D. All right, so we're taking out some yellow. So the 4 is way down here, so it's just a little bit. Oh, way too much. Way too much. So let's pour some back. Just a drop. No, that's still too much. Oop. All right. Now we have to add some with the dropper because we got to get it to 4. I know it's hard to see. Okay, there we go. There's 4 milliliters. Now we pour it into test tube D. Okay, step 5 says, from test tube E, take 7 milliliters and add it to test tube D, and then mix with the pipette. So 7 milliliters from test tube E, pour it into D. Ah, too much. I know you can't see it's not focusing, but the 7 is about here, so there's about a whole milliliter that I overshot, so I have to take some out and the pipette won't reach, so I have to pour it. And I apologize that the video is shaky. I'm holding the camera with one hand and trying to do all this other stuff with the other hand, so. Okay, good, there we go. I'm gonna call that close enough to 7. See that? You can see a little bit better now. That's actually perfectly 7. So we're going to pour that into test tube D. Okay, so we're going to pour some blue into yellow. What color do you think we're going to make? Any guesses? Do you know what blue and yellow make when you mix them? I think you do. Oh, almost missed. And if you guessed green, you were correct. All right, so the next step is step 7. From the beaker of, I'm sorry, we're on 6. We're on step 6. From the beaker of blue water, measure 4 milliliters and pour it into test tube F. Now the beakers are referring to these cups of water, okay? Four milliliters. Boom, right there. I nailed it. And pour it into F. Okay, now we're on step 7. It says from the beaker of red water, measure 7 milliliters and add it to test tube F. 7 milliliters. So we're going to try to get it to about right there. And again, I know you can't really see the numbers, and I apologize for that. I think you're getting the idea of this, though. All right, and I think I hit it. I think I hit my mark. Yep, 7. And that goes into test tube F. So there's already blue in F. Now we're going to add some red. What color do you think we're going to make? I think you know. So on camera it looks like an orangey brown, but here there is a tint of purple to it. It's probably not as purple as it should be, but it's a little purple. Okay, step 8. From test tube A, take 8 milliliters of water and pour it into test tube B. I think you can see where we're going to go with test tube B. We're going to take some red, and that's not as red as it should be. This is a little more orange than red. Okay, so 8 milliliters to right about there. There we go. Well, it's not focusing, but it's there. And pour that into B. All right. Okay. So, step 9. From test tube C, take 3 milliliters and add it to test tube B. Okay, 3 is way down here. 3 is just a little bit. 3 is way down there, so. There. All right. Yellow and red make what color? Orange. And there we have it, you guys. Okay, so now let's go fill in the data table, okay? For test tube A, all we did was we added red water to test tube A, okay? So that's what you're going to write in for the color of water for test tube A. B, we added yellow to red, and it might not be showing up as orange as as it is, but test tube B is orange. So you're going to type orange into the color of water for test tube B. C is a pretty clear yellow. D looks green to me. E is blue. And F, it's supposed to be purple, and it's just got a barely purple hue to it here in class. It's more of a brownish orange, which doesn't sound like a real color, but you can put purple if you want, or you can put in the color that you see here on the video. Okay, it's up to you. This is an observation lab, and what you see is what you can record for your data. Okay, so get those colors in the data table, and next we will measure the final volume of each one. Okay, let's take a look at the final volume for test tube A. What do you think? Is that 11, or would that be a little less than 11 if we're looking at the bottom of that meniscus? I think it's a little less than 11. I think it's just below that 11 line. So we're going to call that 10.8 milliliters. Okay, test tube B. Okay, so the big line under the 11 represents 11 milliliters, and it's in between 11 and 12. Now 12 isn't labeled with a number, but we know what's in between 11 and 12, 11 and 13, and that's 12. So I would call that 11.4. 11.4 milliliters. Okay, this is C. It looks like C is the same as A, about 10.8 milliliters. Okay, and D, we'll call that, if we're measuring to the bottom of the meniscus, that looks like 10.6 milliliters, 10.6. Here comes E. We'll call that one 10.6 as well. You can really see that curve. That's caused by the surface tension of water. Okay, the water molecules are, they want to stretch out. Even though they're sticky, they want to stick to the side of the cylinder, and that makes them sort of creep up, each side of the cylinder. Okay, 10.6. F. I think we can call that 11, exactly, because we're measuring to the bottom of that curve, not the top, the bottom. So let's call F 11.8 0.0 milliliters, or just 11 milliliters. Okay, so now that we're finished, we could take a look at the evidence part, okay? It says, does your evidence match your claim? So you are going to take a look back at the data table. You are going to see which test tube had the highest final volume. You're going to compare that to your guess that you made in the claim, okay? And you're going to base your response on whether or not the evidence matches your claim. So if you said in the claim that I think test tube E will have the highest final volume, and in your data table E does show the highest final volume, your response will be, yes, my evidence does match my claim. If it is different, then you will simply write, no, my evidence does not support my claim. So you could type that now into the lab sheet. Okay, last but not least, we have the reasoning part, okay? And the reasoning is a two-part response, okay? Number one, describe how to measure liquid volume, okay? The information on how to measure liquid volume, I gave it to you in the background. There's a whole paragraph of information on how to measure liquid volume on the first page of the lab, okay? Let me scroll back and I'll show you. Okay, all of this stuff here where it says background information, that is all information on how to measure liquid volume. So all you need to know for your response to part one of the reasoning is right here. But here's the thing, you can't just copy and paste it. You have to do what's called paraphrasing, or you have to take this information and put it into your own words, okay? Now, you don't have to use every single speck of information. Okay, so you don't have to use every single speck of information that's in this background paragraph, okay? What you should include is you should paraphrase this first sentence at least, okay? It says liquid volume is measured with a graduated cylinder. You should be able to put that into your own words. Just flip-flop. Put the last half of the sentence in the front, and that's how you, one way to paraphrase, okay? Another thing you really should mention is the meniscus, okay? We made a big deal about measuring to the bottom of the meniscus, so you should be able to explain what that is, okay? And that to accurately measure the amount, you take your reading at the bottom of that meniscus, okay? Let's go back to the reasoning because I want to show you part two, because we're doing this virtually, you guys. Part two is going to be really difficult for you, okay? It says, were your results the same as your classmates? Well, I'm your classmate, and there's really no way to answer that because you all did it with me. What I would like, and so part two is, I'm going to make it optional for you guys. But if you can, look at the second sentence. It asks, what were some factors that might have contributed to your results, okay? Do you think every kid who did this, do you think everyone did it exactly the same way? Do you think every kid got exactly the same colors and exactly the same amounts of liquid in their test tubes? I'll tell you right, you know, I'll answer that question. No, not everybody got the same results. And all I'd like for you to do, if you can, and it's optional, but I would like for you to maybe think about what you saw in this video, and maybe think about, you know, ways that might have contributed to kids getting different results, okay? You know, did we spill a little bit? Was the red in the red cup, was that really red to start with, or was it more of an orange red? Okay, there's really no way for you to know that because you didn't see them all. Was the blue really blue to start with? For every student, was the yellow really yellow to start with? Okay, there's all kinds of variables that went into the different results that students got. So if you can think of a couple that might have contributed to different results, that's all you have to do, okay? All right, I hope this video was helpful. Once you finish With part 1 of the reasoning, you did your evidence. Make sure you click turn in to turn in the lab, okay? And watch this video as many times as you need to help you to understand and to help you to, understand what the lab was all about, okay? And you can shoot me emails too if you're still having trouble. So just drop me an email and I will be sure to get back to you and help you out, okay? Thanks, guys. Bye.